Hey guys! Welcome back to my channel. In today's video, we're going to be learning about exponents and their properties. Let's get started. So let's start off with a few basic rules. Let's say we have a to the second times a to the third as shown in our first problem. If we see something like this, where both of the bases are the same, then our answer will be that common base, which in our case is a, and the exponent will be the sum of these two exponents. So 2 plus 3 is 5. So whenever you see something like this, you add the exponents. Our next one has a to the third squared. So when seeing something like this, our answer is going to be the base, which is a, and then the third exponent on top of the a is going to be multiplied by the 2 on the outside. So 3 and 2. So 3 times 2 is 6. So when you see something like this, you always multiply. Our next one has a to the fifth over a to the second. Whenever we have more than one base, we always need to check if they are in common. If they are, then our answer is going to be the base. And in this scenario, where we have a fraction of a to the fifth divided by a to the second, we're going to take the exponents and we're going to subtract them. So 5 minus 2 is 3. So in these scenarios, you always subtract. Our next one is a to the power of 0. So in this case, it doesn't matter what your base is, because anything to the power of 1 is always going to be 1. So whenever you see something to the power of 0, the answer is always going to be 1. So the next one we have is a to the negative third. Whenever we see something with a negative exponent, we just take the entire problem and we put it underneath 1. But the negative becomes positive, so you can write a to the third. So what we essentially did was take the reciprocal of the original fraction. Our next one is a to the power of 1 over 3. Base is raised to a power of a fraction. Whenever we see this, our answer is going to be a, and then we're going to take the root of whatever the denominator is. So in this case, it's going to be a cube root. So whenever we see something like this, we take the root of it. Our next one is negative 4 squared. So for this one, you might think that the answer is 16, but it's actually not. This 2 over here is only squaring the 4. The negative is on its own. So you first square the 4, which would give you 16, but then you have to add the negative onto the end, because the entire number, negative 4, isn't in parentheses. So the answer for this one would be negative 16. Our next one has the entire negative 4 in parentheses. So we can just square the entire thing and we can get 16. Now that we've reviewed the basic rules, let's try some practice problems. So here's our first problem. 2a squared times 3a to the sixth. The first thing we need to do is multiply these constant terms. The constant terms are going to go right in front of the product of the two exponents. So first thing, we do 2 times 3, which is going to give us 6. Now we can move on to multiplying the exponents. So we have a squared times a to the sixth, because the 2 and the 3 are already out of the way. So a squared times a to the sixth is going to be equal to a to the eighth, because since they're being multiplied, we have to add the exponents together. So 6a to the eighth is our final answer. Our next one says 24 times b to the ninth over negative 3b to the fifth. So again, to solve this one, what we're first going to do is get these constant terms out of the way. So we're going to do the operations as we would normally do on regular numbers. So 25 divided by negative 3 is going to give us negative 8. So now we don't have to worry about our constant terms. Next, we look at our exponents. B to the ninth over b to the fifth. So this one is a fractional one. So in these cases, we subtract the exponents. So we have our common base, which is b, and then we subtract 9 and 5. So 9 minus 5 is 4. So our answer is negative 8 times b to the fourth. Our next one says 7 times c to the fourth to the power of 2. So for this one, we use this rule right here. But first thing we have to do is get those constants out of the way. So it's going to be 7 to the power of 2 is 49. The reason I didn't raise it to the power of 4 and then the power of 2 is because this fourth power only applies to the c. You could visualize this as 7 times c to the fourth squared. So that fourth power does not apply to the 7, which is why I didn't raise it to the fourth power and only raised it to the second power, which was outside the parentheses. From here, we take c to the fourth and we're raising it to the second power. So over here in our exponent rules, it says to put down the common base and then multiply the two exponents. So we have 4 times 2, which is 8. So our answer is going to be 49 c to the eighth. This one says y to the negative second times y to the negative seventh. So this one actually involves two different exponent properties. We have the first one over here where two exponents are being multiplied with each other. And then we also have the negative exponents rule. So in this rule here, it says we have to add the exponents together. So we're going to have y to the power of negative 2 plus negative 7, which is going to give us negative 9. Now we have y to the negative 9, and we need to switch it to a fraction to make that negative 9 positive. So we're going to use this one down here where we're going to write y to the ninth without the negative in front of it, and we're going to put it underneath 1. So our answer is going to be 1 over y to the ninth. Our next one says 125 to the 1/3. So this one doesn't have any variables, so we're going to get a numerical answer. So we're looking at this rule right here, where the base is raised to a fractional power. So what we do is the denominator is the root of the base. So our base is 125. And then we take the root of whatever number is in the denominator. So since there's a 3 in the denominator, this is going to be a cube root. So the cube root of 125 is 5. So 5 is going to be our answer. So now let's make things just a little bit harder to get a few more challenging questions. So over here we have negative 63 times x to the 5th times y to the 7th over negative 9 times x times y. So remember, first thing we do here is we need to get rid of these constant terms. So negative 63 divided by negative 9 is 7. And now we don't have to worry about those terms anymore. So now we're on our variables and exponents. You see, if we try to multiply x to the 5th and y to the 7th, it won't work because their bases are different. So we can't simplify the top or the bottom anymore. So we'll just have to straight divide the exponents. So let's go one exponent at a time. We'll first do the x. So we have x to the fifth divided by x. And you can imagine in like invisible 1 in front of this. Because anything to the power of 1 is the same thing as the number or the variable itself. So we can just imagine an invisible 1 up here to make things a little easier for us. So we have x to the fifth, and on the bottom we have x to the first. So the rule that we're using here is the fractional exponents. So whenever we see something like this, we have our common base written, and that's going to be to the power of the subtraction of the two exponents. So 5 minus 1 is going to give us 4. So we're going to have x to the fourth, and now we're going to do the same thing with the y's. So we're going to have y, and then we're going to subtract the exponents on both of the y's. So 7 minus 1 is going to give us 6. So our final answer is going to be 7 times x to the fourth times y to the sixth. So over here we have 3x to the second times 4y to the fifth. Remember, first things first is get rid of those constants. 3 times 4 is 12. Moving on to the exponents. So we cannot multiply the x and the y terms together as we said before because their bases are not compatible. So all we have to do in this scenario is just write both of the exponents after the constant that we wrote down. So the only thing we multiplied was 3 and the 4. Since we can't multiply x to the second times y to the fifth, it means that we can't add together their exponents. So they're just going to be left out separately on the side. So for this one, 12 times x squared times y to the fifth is going to be our answer. This one says 2x to the fourth y to the sixth times 6x squared y over 3xy to the eighth. This is probably the most complicated problem we've had yet. So the way I'm going to tackle this is I'm first just going to multiply these top two together to get one singular term and then divide that by this one over here. The first thing we need to do is get rid of these constants. So 2 times 6 is 12. Now again, we have both x and y variables. So the x variables can only be multiplied with the x variables, and the y variables can only be multiplied with the y variables. So let's start with the x's first. X to the fourth times x squared. This is using our first rule. So multiplying these together, we're going to have x, and then we're going to add 4 and 2, and we're going to get 6. So we have 12x to the sixth, and now we're going to do our y terms. So we have y to the sixth times y, which is again using the first one. So for our y terms, we're going to have y to the power of 6 plus 1, because remember there's an imaginary 1 right here. So y to the power of 6 plus 1 is going to be equal to y to the power of 7. So 12x to the sixth times y to the seventh is going to be our numerator that is simplified. So I'm just going to replace this over here. So now we have 12x to the sixth, y to the seventh over 3xy to the eighth. For this, we're going to have to use a different property, which is our fractional property again. Once more, first thing we do is get rid of those numerators. 12 divided by 3 is equal to 4. Moving on to our constant terms. Again, x and y's are different, they can't be multiplied together. So we're going to start with only the x's first. Remember the imaginary 1 on top of this x, this plain x. So we're going to have x to the 6th divided by x to the 1st. And remember, we subtract the exponents, so we're going to end up having x to the power of 6 minus 1, which is 5. For our y's, we have y to the 7th and y to the 8th. So our y term is going to be y to the power of 7 minus 8, and that is negative 1. So our answer should be 4 times x to the 5th times y to the negative 1st. But this is not fully simplified because of that negative in front of the y power. That negative makes it not fully simplified. In algebra, if there's a negative in that exponent, it is not considered simplified. So what we're going to have to do is use yet another rule, which is the negatives rule, and we're going to have to make sure that this is fully simplified. So remember, this negative 1 only applies to this y over here. So the 4x to the 5th is going to stay right where it is. So we're going to have 4x to the 5th times, and then y to the negative 1st. So remember, y to the negative 1st is going to be equal to 1 over y to the 1st. Remember, we take the reciprocal, get rid of the negative. So 1 over y to the 1st is the same thing as 1 over y. So I'm going to place this right here. So 4x to the 5th times 1 over y is going to be equal to 4x to the 5th over y. So looking at this one, this is now our final answer, 4x to the 5th over y. So that's it for today, guys. I hope everything was clear and easy to understand. If you like my videos, please like and subscribe, and also be sure to drop any questions you have about this video or any of my previous videos in the comments section below. Thank you so much for watching. See you next time. Bye!